Hello, this is my CNC plasma cutter. It's a practically complete do-it-yourself machine. The only thing that really bought is the plasma inverter. Here is it. And practically all the parts from this machine are made from the scratch. Let's take a look to each part to see how did I make this, because it's really cheap and everybody can afford it, but a lot of hard work is needed. Okay, starting from the motors. This one are Chinese one-tie stepper motors. Nothing new with that, nothing impressive. They are hard torque, 76 millimeters long, and the main linear guides are made from a H-beam construction beam. Okay, you can see there how the H-beam. Okay, but the surface, of course, is treated. It's polished, and now it's really flat and shiny. I think, well, look at my hand. Okay, it's really shiny, and the linear block bearing is made with single normal rotating bearings, which ones is on the linear guide. Okay, this block has 8 bearings, 1, 2 in the sides, 2, another 2, and from below there's another 2, 1. Okay, and 4, 6 in this half, and another 6 in this other. 12 bearings per linear bearing block. Okay, the screw. In order to convert the rotating motion of this motor into a linear motion, which is required to move one of the axes of this machine, I've used an M14 screw. Okay, and here it's a nut. I don't know if you can see it, but there is a nut, and all these screws are for adjustment, and there is practically no backlash. Okay, no backlash at all. I think a quarter of millimeter, which you can eliminate completely by software. Okay, this is the X axis. This one is the Y axis. Okay, and this is the Z axis. All these pneumatic pipes and stuff is provisionally here, because I've been doing a lot of changes the last day. And the main wire holder, I don't know how to call this, but when the machine is moving, all these wires are rest here in in this rest place. And this is the plasma cutter, Cat 50, a Chinese one. I think it's pretty famous. It doesn't work so bad, it's good, but the internal construction, it's really well, it's very cheap. Okay, this one cost me about $500, and this is a special one because have a pilot arc function. Okay, this was connected to the nozzle, and this allows to start the arc inside the plasma torch and then throw it out. But the main problem is this system, this pilot arc function, works exactly as a Tesla coil, okay, a 3 megahertz Tesla coil, and that is a big problem because a lot of electromagnetic interference was generated, and my CNC controller, okay, was affected by them. Okay, this is the MOSFET and diodes of the half of the inverter. The half bridge is here. Here you can see the Tesla coil, the high voltage high frequency generator, which puts a high voltage source in series with your electrode. Okay, maybe 10,000 volts, something like that. Okay, here is the main control boards and system. These are 3 normal, complete normal Toshiba stepper motor controller. These are the current sensor from the last bit. Okay, now I'm going to remove the nozzle to see if wear has caused a lot of damage. Okay, I think it's usable, but the hole has moved from the center. Now it's not concentric anymore, and well, I think this can cut, but not a precise cut. Okay, let's see if I can show. Okay, there is the electrode. Okay, I'm gonna pull it out. I'm pulling, but it's this is made of aluminum, but in the center there is a tungsten insert. Okay. Wait a moment. Now the electrode is out, and there is a little of wear here too, but not a lot of. Okay, the tungsten insert is in correct position and not wear on it. Okay, this square has been cut by the torch. Okay, you can see there is no real quality like this. This cut is a professional torch. Okay, and there is a big difference between this and this. What I'm gonna do is to convert this torch into a blowback torch or a 0 voltage arc starting torch, and the next torch will be a mix of the two worlds, the precision of this one and the low electromagnetic interference of this one. Okay, the cutting quality of this and the easy arc start, contact arc start system of this torch. Okay, to compare, here is a Chinese plasma cutter torch. Okay, a very cheap one. You can find this on eBay for under $30, and this is a ceramic. This ceramic works keeping the air that comes from that little holes, from these little holes 1, 2, 3 and 4. This ceramic makes the air to pass through the nozzle and allows the temperature to be lowered. Okay, this is the nozzle. This cross is there to when the torch is cutting a flat piece and touches it. If there were no cross there, the air and the plasma has nowhere to go except from burning the nozzle. Okay, this is a way for the plasma to escape when touching the workpiece. Okay, inside, this is the electrode. Okay, not very impressive. This is a new one with no wear. Okay, and there is nothing more inside. Okay, it's very simple. The cutting air. There is two types of operation gases here. Okay, but it uses air as the two gases. And okay, the cutting gas flows through here inside the nozzle. Okay, and comes out from this hole. And the sealing gas, which is air too, comes from these 4 holes to seal the cut, but also to keeping the nozzle temperature low. Okay, this is let's unscrew this inside. This is the pilot arc, the nozzle connector, and this vinyl pipe is for electric is to prevent an electric spark to appear when the pilot arc function is working. And this is where all the air goes in, and also this is an electrical terminal which connects the inside electrode. Okay, no more mystery here, pretty simple. Let's put back the ceramic on.